Hi everyone, what we're looking at today is we're looking at applications of circular functions. So how do we actually use them and how do they make sense to everyone? So what I've got behind me is a example. We talk about water levels at the dock. Water levels are a very common, very easy to use example for circular functions because they follow a pattern where the water comes in and out and the tides and the water level rises and falls sometimes multiple times inside a day. So water level at docks, also we can use things like temperature. Temperature generally tends to go up and down over the course of a day. And then there's also like the movement of particles. They tend to follow like they fly around a particular point. We can also model those using circular functions. So, what's strange about my equation behind me, aside from the dodgy handwriting? What haven't you normally seen inside that's a circular function until now? Yeah, T. Oh, well, T. Pronumeral is a pronumeral is a pronumeral. What's next to the T that you don't normally see inside a circular function? Yeah. So that pi is going to do something to help us out. What is the period of that graph? All right. What is the period of the graph behind me? It's 12. It's not 12 pi. It's not any fraction of pi. By putting that pi symbol in there, when we're working with radians and we're working with the period of a graph, we can simplify it down and get rid of the pi. So in this case here, if the period is 2 pi on n, and n is pi on 6, then I'm going to have 2 pi divided by pi divided by 6. Now, when we divide a fraction by another fraction, the denominator goes up there, so it becomes 12 pi on pi, and then the 2 pi's are going to cancel out. So it's now just left as being 2 times 6, which is 12. So what that means for us, though, is that when we draw it, it's not in multiples of pi along the scale. We can just go to straight hours. And if we want to model the water level over the course of a single day, by having that pi in there and have it being pi on 6, means that we can cleanly work out what we need to work out. So first things first, let's get this drawn up onto our CAS. So f of t, well, because we're using the CAS, we don't need to put in the f of t because it's covered by the y1 for us. Pi x on 6 plus 3. So clear the graph and draw the graph. Ooh, nope. There we go. All right. So, if I'm caring about the course of a day, I want to start at 0 and I want to move through it. I want to move through a whole day. So I've got here behind me. A whole day. What do you notice that's weird about our tides graph? Think about this graph. The line represents the water level. All right, so it's not centered at 0 because we're talking about, on average, the center line is where the water level is. However, if you look at that graph carefully and you think about it logically, that line represents the water level at a particular location. It's f of x meters deep, the water. Yeah, negative depth. How does that work? Does it work? All right. What I want you to think about is, where are we? We're at a dock. And the point is that the dock has a harder floor than the rest of the ocean. So you could have the ocean, then have a dock that artificially changes where the floor is, and that's what's showing up on the graph here, is that the water can go below the concrete dock floor. So what does that definitely mean we can't do if we're thinking about boats on a dock? All right, so if we're thinking about boats at a dock and we're trying to get boats into the dock, and the water level is negative, that means there's no water in the dock. So what does that mean for the boats? All right. What that means is that the boats definitely can't come in because there's no water for them in the dock. Therefore, they can't enter. All right. So what we need to do as part of this... Can't remember why that's there. All right. What time... When is my water level negative? When is my water level 0? All right. So thinking about, so the context is, when is the water level 0? But in the context of the graph itself, what value am I looking for? What graph terminology am I looking for when I'm trying to solve this problem? when is the water level 0? I'm trying to find the x-intercepts. So, in this case here, we'll go analysis, gsolve, root, and that will pick up our x-intercepts. So, we've got here 7.619. 6793, and then on our next one we're going to have 10.380321. But over the course of a day, is that all? Over the course of a day, is that the only time the water level is down? No. So then I have 19 point... What do you notice about the decimal places comparing? So we got all these decimal places, comparing it to the ones I already wrote down. What's the difference between them? How many units? Think about the period of the graph. When does the graph repeat itself? It repeats itself every 12 hours. Therefore, of course, the intercepts are going to be 12 hours apart from each other. So, to prove my point, the next one along will be at 22.380321. And there it is, 22 point. So the next one will be at 22.380321. Right. So, slight problem here. I want to know what time it was. But can I even use those? I want to know what time it is, but all I've got are decimal points. Time doesn't have decimal points. So what do I need to do next? How do I convert these decimal points into minutes and seconds? Because clearly I can't do anything with them. I can't just say, oh, it's at 7 hours and 0.619 hours. That doesn't make sense. People use minutes and seconds. So that's 7.6196 hours. So I need to take those decimal points and I need to do something to them. Alright, so this will go a little easier if I use the normal algebra section of the CAS. So I'm going to Copy that equation so I don't have to type it out again. And I'm going to go solve 0 equals and what I'm going to do is I'm going to solve it over the course of 0, 24, comma x, and it's going to give me the points there. Now, as you can see, the decimal points are the same for each part of the cycle. So what I'm going to do is I'm going to take the decimal points and then I'm going to multiply those by 60. And it's going to say 30, so it's 37. So this time over here is going to be at 737.18. I still got decimal points. Now, if I didn't care about seconds, if I just said to the nearest minute, what would I do? Round up or round down? Am I rounding up or rounding down if I just care about the nearest minute? Yeah, I'm rounding down. But if I cared about nearest second, what I would do is I would take those decimal points and multiply them by 60 again. And that I would round up to 11 seconds. So it's at 7:37 and 11 seconds. Now, conveniently, because the 19 has the same decimal points, all we have to do is add the 12 hours onto it. All right, so by doing this, we've done twice the amount of work already. And then to do the last one, we'll take the decimal points off the 10, multiply them by 60, convert that to decimal. Obviously, remember you can, if you know you're going to be doing multiple things in decimal form, you can change that. Click that, changes it over from standard to decimal. So that's 22.819. So it's at 10 dot. We're at 22. So now all we need is the last little bit. Take the decimal points, times those by 60, and we'll get 49.15. So we will round that down. 49. And then, of course, because this one here is 12 hours after the first, so we've got 7:30 a.m., about 10:30 a.m., and then 7:30 p.m. and 10:30 PM. So those are where our water level is at 0. So going back to the graph, the center line isn't at 0 because what have I done? What have I done to my equation to move it up? Yeah. So by putting the +3 on there, I have taken the entire graph of 4 sine pi x on 6, and I've just moved it up. So I've just picked it up and moved it. That, of course, changes where the intercepts are. It doesn't change when the maximums and the minimums are. It does, however, change how high or how low they go. Because if you look at it, what is the highest value on my sine graph there? It's 7. And what is 3 plus 4? Also 7. So I move the center line, but the amplitude hasn't changed. So the highest value is going to be 3 plus my amplitude, and then it's going to be 3 minus my amplitude. That's why the graph goes all the way up to 7 and down to -1. So when you're drawing these, it might help for you to, at the very least, get the shape right, sketch out 4 sine to just draw that one. Sketch out the general shape, and then just add 3 to everything to move it up. Right? Because the shape of the graph is exactly the same. The only thing that changes is where the center line of my graph is. So normally the center line on the red graph is at 0 because everything balances around from where 0 is. However, that obviously changes when you move that center line up or down. So you can indeed move it down, but with a minus, but we're not worrying about that right now. So, if I was asking you a question like this on a sack, I might ask you something like, if the boats can only be loaded onto them when the water level is 5 meters or above, what times would that be possible during a day? So if the boats can only have stuff put onto them when the water level is 5 meters or above, what times of the day can that possibly happen? So the water level at 5 meters. I can only do stuff with the boat in the dock when that water level is high enough. Yeah, so I need to find x when y equals 5. So if you can only f of t is greater than 5, when can you load the boat? So, that is correct. We just need to put in 5, draw. Over the course of a single day, how many times in the day is the water level above 5? How many blocks of time is it above 5? All right, 2 goes back to what the period goes back to the number of cycles it's going to repeat in a single day. So in that case here, we've got two blocks. We have got this one here, and we've got that one there. So now what we need to do is we now need to figure out what time those are. So I'm going to go, to make my life a little easier, I'm going to go back to my original question, and instead of 0, I'm going to put 5 in instead. Convenient. My idea to put 5 in there, and look, so we've got here 1, 5, 13, and 17. Well, I'll just go back and check the graph, and we do analysis GSolve intersection. Oh, look at that. Just so happens that because of the way circular functions work, that value that I picked happens to perfectly cancel down and make things exact. For example, what is sine of pi on 6? It's a half. So 4 times a half is 2. 2 plus 3 is 5. So I've got 2 windows that I can do it. I can do it from 1 a.m. to 5 a.m. Or I can do it from 1 p.m. to 5 p.m. Just because if I click on here, I go across, 13, 17. So you're going to need to be able to translate between these whole number values, so 13, 17, and turn them back into AM and PM. Now, if there were decimal points involved in here, which they could have well been if I had chosen a different number, you would do the same thing as what we did above. Take the decimals, multiply them by 60. That gets you the minutes. Then you take the decimals of that and multiply that by 60 to get the seconds. So, my question for you is, for how many hours in a day can someone load up a boat? How many hours in total can someone load up the boat? 8. All right, because I've got a 4-hour window. So there's 4 hours here, and I've got 4 hours here. All right, so the boat might be in dock the entire time, but it could be one of those like boats that needs to be a particular height for the water so that everything lines up so everyone can load on the gangway. if I was doing something like this on a sack, I might give you something a little bit more devious. Like I might say, oh, yeah, it has to be 2.5 meters. And then you would follow the same process. Analysis, G-solve intersection. And then you would have to find what all those times mean. Now, obviously, if I have negative time, I can't use that because I only care about the course of a single day. So, where these questions get tricky and weird is when they start being things other than, nice, clean numbers. So, if we've got pi on 6 as the period, then the graph is going to repeat itself twice in a single day. Pi on 12 will mean it repeats itself once in a day. But what about if it's something like pi on 8? Alright? Something like pi on 8. Or even better, pi on 9. Because if you go through and you look at where the center line is, at midnight on Monday, the water level's at 3. But if you go to the end of the day and you go to 24, where's the water level? It's not back at that. It's all the way up here. So what this means is if you are modeling over, say, the course of a whole week, you would need to change how you think about your graph. Because if I was to repeat the same questions that I've been doing, but with different values, obviously, if I was to look at it over the course of a whole week, I would need to change my maximum. So let's go to 200. All right, so we've got 200 hours. All right, how many hours are in a week? How many hours in a week? 168. Thank you. So 200 is a bit overkill, so we'll go to 168. And what I'm going to do is I'm going to put a scale of 12 in here, just to help me visualize it easier. So over the course of a whole week, that's what the water's going to look like. And if I was to say, try and just solve what I've got going on here, find the intersection between 3 and my graph, I'm going to have all these strange numbers. So 0, 9, 18, 27, 36. So it's basically running down the 9 times table. But if I was to ask you what 45 means in the context of the question, how would you answer that? All right. So the initial context of the question is X or T is hours after midnight Monday. And I've got here X is 45. So what does that mean in the context of the question? All right, that's 45 hours after midnight Monday. So what time is it? All right, 45 hours after midnight Monday puts us into Tuesday, and then correct, 9 p.m. Because 48 hours is end of Tuesday starting Wednesday, so 3 hours before that gives us Tuesday 9 p.m. All right, so you have to be able to take some, especially over these longer periods of time, take these and translate these back into the context of the question. So over the course of a week, you can see how the tides follow an irregular pattern. They're still predictable, they're still modelable, but it's not a nice, clean over the course of a single day.